Okay, it seems to be in this recording. Okay, testing. All right, good. So we'll be doing the tutorial on the VPL, and we'd like you to do your practical test on the VPL because it will be much safer for you, particularly if the computer that you're on stops working, which definitely is a real possibility. So it allows us to very easily move you to another computer, and then you can just continue. Otherwise, we would only be able to restore whatever you'd uploaded to Eve, which some students don't do that regularly. So that would be quite a risk. So that's how we will run the semester test. So that's how I'm going to do this tutorial. And in this tutorial, we'll be basically doing a generic, so a templated two-dimensional container of type whatever, and we'll do it with the double square indexing approach rather than the round bracket approach, because it is slightly trickier. All right, so let's begin. All right, let's make a new file. All right, and that's going to be, call it a grid. So there'll be a grid.h as well as a grid.imp. Remember, we're going to invert the hash include order. Instead of including a header file into a CPP file, we'll rather rename that to a .imp file and bring it into the header file through a hash include, because the templates don't work well across multiple files. So the normal technique is to write everything in the header file, but that obviously violates the principle of separating interface and implementation. So we will do it manually and use an include to join the two together at compile time. All right, so that's that. Save. And let's make another new one. So grid.imp. Okay, we won't have code completion for that in the not code completion, the syntax highlighting in the VPL, I don't think, but that's all right. We'll make do. All right, and then likewise, the way in which we achieve the double square indexing is the grid contains a one-dimensional array of row objects, and each row implements the one-dimensional, contains a one-dimensional array of type T. When you index into the row, it returns the value. When you index into the grid, it returns the row, and that overall gives you the system that allows for double square indexing. All right, so we'll create classes to represent our rows. So that'll also be row.h. as well as row.imp. And we should be good to go. So let's start with the the header file. So just do my guard conditions. All right, it's going to be a templated class containing a one-dimensional array of type T. So we'll need to use the template keyword, introduce the type parameter. We'll use the type name keyword rather than class because it's confusing, but it'll have a single type parameter T. We will call it row. And inside its private state, it will contain a one-dimensional array of type T, which we can call data or values or whatever you want to call it. We'll still use a regular integer to represent the length. And I'm going to have a well, an allocation function, really. Let's call it, I don't know, let's call it redim or something to size the row. And we'll also be doing things like copying and so on. I can do those more manually if you prefer, just for practice's sake. Let's maybe do that. All right, so what do we want? We're going to have a regular no args constructor for the row. We're going to have a destructor to delete the array. Because we have a destructor, we need a copy constructor and overloaded assignment operator. So we will create our copy constructor. It will take a const row reference, but the rows aren't just any rows now, they're now generic rows, so they're rows of type T. So you can kind of think of the name as almost changing to row T. So a row of type T, reference. And then also a copy constructor, which will give us back a row of type T reference, called operator assignment, and it will take a const row of type T reference for the right-hand side. And we'll need an accessor to get the size. And we will also need a accessor mutator combination in the form of the square indexing operator, which we will implement here to return the underlying array. And then when we get to the grid will contain an array of rows. So this should be enough. Let me just think. Copy constructor, assignment operator. We'll handle, basically what we'll do is in the grid, we'll handle things like streaming and whatnot to allow you to stream the grid out. We don't need to do that in the row as well, because the users of the grid don't need to know that a row even exists. So all we need to do is to be able to access the length and the size and do the management like that. I think that should be okay. So we'll add stuff as we encounter it and decide that we need it. And then to join the header file to the CPP file, in this case, we will need to bring in the implementation file into the header file. All right, so here we are. We'll now need to fully qualify all of these, and it'll take a little bit of time. And just remember that we need to put the template keyword, as well as that the name of the class is now row of type T. Okay, and we'll do that with every single one of the member functions. Okay. There. All right, that should be enough for that. So let's just do the basics. I'm not going to go too crazy with too many helper functions and so on, because with the row, at least, it's very short. So for the allocation function, there's no meaningful way to initialize anything, because what would you put as an initial value that's valid for all things? You could say 0 would count for a lot of things. You could initialize a Boolean to 0. You could initialize pointers to 0. You could initialize a real number and integers and all of those to 0. But you can't initialize a string to 0 or a student to 0. So there's no meaningful initial value that you can apply to everything. So all we really need to do is to allocate the array, as well as store the length. Suppose we should do some range checking, which I will do. Strictly speaking, I'm going to be using these a lot. Maybe we could have them in another header file that everything's going to include. It's fine. I'll just do it manually. All right, so let's just do a safety check for the range So if int length is less than 0, it's a problem. In fact, you can even say if it's less than or equal to 0, because a 0 length container makes no sense. So then we will treat that as an error. And we'll need to make use of exit, which comes from C standard lib, as well as IOStream. All right. So once we've output our error, we will exit with an error code. I'll just put that in the error file here, just as a regular int. All right, and once that's done, we can store the length as well as allocate the array. And it's an array of type T, because when we compile this, T will be substituted with whatever type we pick when we instantiate it in main. So it'll be integers or strings or whatever it is that we want according to the user of the class. So that should be enough for allocating the array. Deleting, it's only a single line, so there's no need for a helper function, I'd say. Just do it manually when we encounter it. Copying, I suppose we could, but it's fine. All right, so for this, we will simply read with some default value, hard code it here, make it 10, let's say. Strictly speaking, we should have a constant for it and all of that, but that's fine. We can do a class constant, no harm. All right, static const int default row length. All right, for the copy constructor, first thing we need to do is we need to allocate our array and make it as big as obj originals. Let's call it obj origin in that case, length, and then copy everything across. I suppose we could have a helper function, but it is just a simple one-dimensional container, so I'll just do it manually here. Length will have been correctly set by the allocation function. And into our array, at position I, we will transfer obj originals data at position I. And that's that. Likewise, for the assignment operator, what do we need to do? We need to make sure that we're not doing self-assignment. So that's the same process as always. Check to make sure that this is not equal to the address of the right-hand side. If it is, then we do the work. So if it is, then we've already done the work. So we can simply return ourselves to support the chaining. And if it isn't, then we need to do work. So we need to delete our array. And we need to allocate it with the size of the right-hand side. And then copy everything across. into our own data at position I from the right-hand side's data at position I. Okay, so far this should match pretty much what I did in class yesterday because it's just a one-dimensional container of type T. So that's that. So yeah, free, allocate, copy, check for self-assignment, support chaining. For the one-dimensional indexing, we just need to check the range. So again, let's do that manually here. If the index is less than 0 or the index is greater than some maximum, then treat that as an error. And exit with an error code, which I guess since we're doing it, we'll already define. Just been putting them there. Ugh, these may as well now be class constants since I've already crossed that threshold. Okay, and if we make it through that, then everything's all right. So we can simply return from our own array at the index's position. Okay, accessing the length is really easy. We simply return length. And I think that's all of the core functionality done. So let's test the rows individually before we move on to putting them into a grid. Okay, so let's make for ourselves a row of integers, let's say, and let's make it, I don't know, 10 big. Put values into it. And then let's initialize it. And let's then also test if we can access values from it once it's initialized. Okay, so let's see if that works, see if we've made any mistakes or anything like that. And let's compile. Blech. Unhappy. Okay, it didn't like template constructors. Why is it moaning about that? Okay, let's just check. Oh, I never made one which took a size. So let's add that. Okay, and okay, hopefully that sorts that out. Let's give it a whirl. See what other problems we might have. Okay, line 13 on row.imp position. Unqualified identifier. Before. Oh, it's a single colon, I think. Typo. All right, let's try that again. Okay, and let's go. Yay, moaning. Yeah, 927, so it's over here. Why are you, right. Let's try again. Okay, so we got the basics, a one-dimensional array of type T. Let's now augment that, and we're going to create a one-dimensional array of rows, also of type T, so that we can have a two-dimensional collection of whatever that we can index with double square brackets, as well as to stream using the stream operators. So let's begin. Make our header file. Okay, at the end of the day, bring in the implementation into the header file. It too is templated, so give it its type name, T, its type parameter, be a class called grid. We'll have a public and a private interface, or public interface and private implementation. It will need to know about rows. So we'll bring in the row here, because it will have a row of type T. Sorry, so it's going to have a one-dimensional array of dynamically allocated rows. So it's a 1D array of row pointers. It's not a 2D array of rows. That would be like a 3D structure. It's a 1D array of rows that were allocated with new. Hence the pointer. We'll call that data as well. The grid will need to know its rows and its columns. Strictly speaking, it doesn't need to keep track of its columns per se, because the columns, it can ask the rows, but this is a rectangular data structure in the sense that it's not a jagged array, because each row has the same length. They don't vary. So we can store it as well. That's fine. So let's just keep it simple and store it. So rows and columns like we normally do. We'll also have an allocation function in here. Today I'm feeling very Visual Basic-y, I guess, so calling it redim. And we'll take in the rows and columns. I'll manually do a lot of the stuff like I did here, just that you can see what's going on the process rather than helper functions some of the time. Because again, even though it's going to be 2D data, it's still a 1D array of rows, so it shouldn't be too complicated. So we should be all right there with just our redim, just like we had over there. So let's try that for now. We will need a no-args constructor. We will need a parameterized constructor. Maybe for this one, because we'll be doing both rows and columns all over the show, let's have a range enforcement. trust me, it's still better than your computer dying in the test. If your computer dies and takes your work with it, you're in a lot of trouble. Whereas if you've been saving here, like you have to save every time before you compile, we can always take you back to your last save, right? The VPL actually keeps a record of all of your saves. We could even take you back to an earlier one if you accidentally delete all of your code or something like that. So it's much safer for you to work on the VPL in the semester test. So that's why we will be going that route. All right, we will need a destructor as usual. Because we have a destructor, we will need a copy constructor, grid of type T, reference, call it obj again, and we will need an overloaded assignment operator, grid of type T. Okay. We're going to have our indexing operator. It's going to return a row of type T reference. And then we're going to have the two streaming operators, or at least let's just at least do output with the stream operators over here for now. So let's have a friend function. It will need to be templated because it's an external function, and it needs to be templated with a different type parameter name to the one that's outside. Otherwise, you'll get error messages about shadowing it. But it'll always be the case that T1 and T are actually the same type. But the compiler can't know that. So that's why we have to just specify it. This will make use of the stream operators. So we'll need to bring in IOStream. Okay, we need to specify both the left-hand side and the right-hand side. The left-hand side will be the stream, the right-hand side will be us. So let's do that. And then the grid reference, type T1 in this case, and since this is for output, it can be a const reference, will be the right-hand side. And I suppose we can do the stream input operator. It's just we'll need a format for specifying the size of the container when you're streaming in. So what I suggest we do is we then take the first two parameters as being the number of rows and number of columns, and then the rest the content, right? So kind of like the reverse of the PPM format for images. We specify the size and then stream it in. All right, so let's do that. So we'll have, again, templated with type name T1. It's a friend function. Bring us an iStream back. Left-hand side is always the stream. Right-hand side will be us, but it can't be a const reference because we are supposed to be modifying us. And that should be good enough because this allows us to, okay, sorry, we do need two stupidly simple things. We need, put them over here before the operators. We will need to know the number of rows and the number of columns. I think we're okay. And I'm actually not sure if we'll need the enforce range because when you try and index into a row, it will check its own range. When you try and allocate the row, it will check its own range. So there's no need to, yeah, all right, let's just keep it, but it's fine. Right, so this should be enough for our grid. Let's do it. Spacing over there. Okay, let's start implementing it. We are including the imp file. Okay, we just need to do our setup. So grid of type T, 2 colons, template, type name T1. Okay. Okay, for functions, you mustn't just blindly do it. Ugh, type what T1, T1, T1. Danger of copy paste. Okay. Okay, these ones will need to be moved over there, be moved there. All right. Right, so these are non-member functions. So we leave them as they are, except we drop the friend keyword. No class name to fully qualify them because they're not actually part of the class from C++'s point of view. All right. So that out of the way, we should be able to start implementing. Let's start with the allocation function as before. Okay, well, let's start with enforce range since we did decide to go that route this time. So if int value is less than int min or int value is greater than max, then we have an error. And okay, and let's just have a error message or an error code. Okay, and then we do need to bring some things in here. So we're going to need C standard lib. As well as IOStream for the error stream, and iStream and OStream for the stream operators. Okay, so we should be able to do our error messages there. So if nothing happens, it doesn't end the program. Everything's good. I think one thing that might be worth doing, which I normally do, is to make it a const function because we might need to call it from const context. I can't quite remember, but better safe than sorry. All right, so that's that. Now it exists, so now we can safely check our rows and columns. We don't have ranges yet, so let's define them. We don't have maxima and minima. Technically, this one will only handle the rows, I suppose. Ugh. Bit confusing the way I've named it here. So max row length. Technically, this is the maximum number of columns. So let's change that around. Okay, and blah, blah, blah. So yeah, so now we can have the maximum rows defined there, the maximum columns defined somewhere else. So we can enforce our range for the rows, which we want to be at least 0 and at most max rows. The grid H is including the header file for rows, so we will know what the various things are. So enforce range, columns, and 0. Actually, 1 might make a reasonable minimum because 0 doesn't make sense. And max calls. And then once that's safely done, we can actually start allocating. So what do we need to do? We need to allocate the first dimension, which will be the array of row pointers, and then we allocate each dynamically allocated row in each of the positions in that array. So data must be equal to new row of type T pointer array, the size of rows. And then we will go through every row and put inside data in that row a new actual row, also still of type T, and it will be as big as the number of columns. So that should be that. Doesn't seem too complicated. All right, so we'll obviously find our errors in testing. Okay, yeah, I suppose maybe I should make a delete helper function because deleting is actually a two-phase process. We have to loop through the array, delete each row, and then delete the container. So that's something we might do a fair amount. So let's make a free state function. Okay, it will also be templated. And it's for a grid of type T. So we loop over every row. Oh, we didn't actually save the rows and columns. Let's do that. Once we've checked them, rows equal to int rows, and columns equal to int cols. Okay, we loop over everything. We delete the inner row itself. it's not an array, it's a row object dynamically allocated from the heap, which keeps a row, an array for itself. So we don't use square brackets here because when we allocated them, we didn't use square brackets because it's not an array of rows, it's one single row being allocated. Data itself at this level is a row, is an array of row pointers, but the rows themselves are actually objects, not arrays. They contain an array. And then when we're done with all of that, we can delete the outer level array. Okay, now we've got our helper function that makes our lives easier. We can call free state from the destructor. Do we have a default? Yes, we do. So we just need to do one for the number of rows. Strictly speaking, just to keep the naming consistent, the row length in this case is actually the default number of columns. Just going to have to hunt that down inside here. I think that's the default calls. Okay, getting there, eventually. All right, yeah, so the grid level handles the row amounts. The rows handle the column amounts because a row is as big as the number of columns. So here we can simply call our allocation function with the default rows and the default columns. Okay, over here we can check our, or just simply once more allocate, but this time with the specified number of rows and columns. Yeah, straightforward. Copy constructor. Okay, first thing we need to do is we need to free our current state and then redimension based on the number of rows and columns from here. I'm going to call the accessor functions. So I actually haven't decided yet. It's fine. I'm storing them separately, so it's fine. Orig dot rows and orig calls. And then we actually have to copy across. Now this might require some thinking. Let me just, it's going to require our copy constructor here to be working correctly, which I don't think we actually tested properly. So maybe we should just do that first. So before I output anything, what I'm going to do rather is I'm going to make a copy, or rather another row of type int. And then I'm going to assign object new to object 10. And then output from object new, just to make sure that the assignment operator works correctly, because we'll sort of depend on it now. So let's test that. Yeah, that seems to work fine. All right, so inside here, what are we going to do? We're going to loop over the number of rows. And then data at position R is going to give us back a pointer to the row. So we're going to want to dereference that pointer and assign the new row to that place. That should work okay. The other alternative that we can do is we can do it manually. If we want to skip extra reassignments, assign there, that should work fine. And then from our data at position, from ourselves, we're going to need to grab something similar. Let's just see. No, from the other side, yeah. So object original, at position row and position column. So this will rely on our double square indexing working, and that should be okay. That one might need some investigation, but just to go over what my logic is, the array is an array of row pointers. So indexing into R gets us back a pointer to the row, which we need to dereference and then index into it to get the column, and then assign the new value into that. That seems reasonable. We'll have to test it. All right, then we will return our rows and return our columns. You can see why we prefer to work with the round bracket function invocation operator, because with that you can just specify as many parameters as you want and then do rows and columns and just have a simple array internally, which makes life much easier. All right. Okay, much of a muchness. So here we should be all right. We just need to enforce our range from 0 up to, sorry, of int index from 0 up to, in this case, this is the grid. So we're looking at a particular row. So rows -1, and then return data at position R. And that's going to return a pointer again, and this is expecting a reference to come back. So we will just need to dereference that pointer. Should be okay there. Actually, we can make our lives easier here, I think, rather than muck about like this. Is it easier? Let's think. We could go, is it easier? I don't know. You tell me. We could just dereference this and double index into ourselves. I guess that's a little easier to read, right? Marginally. It's up to you. But then again, I'm not sure what the order of evaluation will be here, so I'll still want to wrap that up. I guess it looks a little better. A little better. All right. Okay, so we need the assignment operator. So once again, we'll need to check for self-assignment. So as long as this is not equal to the address of the right-hand side, do the stuff. Once the stuff is done, or if we didn't need to do it, either way, return ourselves. And inside here, what do we need to do? Well, we're being assigned. So first things first is we need to free our current state. Then we will need to allocate space based on the size of object right-hand side. And then once that's done, we can copy. And I do feel like I should have rather had a copy function because using that multiple times. Let's do it. Okay, let's put it with the other helper function as free state. Let's put it near there. Similar story. Nope. Yep. Okay, and then all right, kept the name the same, so it should be all right. We should be okay. All right, seems fine. Then we can rather call free state of, copy state over here and copy right-hand side into us. And then we should be okay, except for the two stream operators. So I'm going to leave the insertion operator for later. For now, I'm just going to do nothing. But for the output one, that'll help us with testing. So let us do that. So we need to loop over every row. And we need to loop over every column. All right, and once we're there, into the stream, not into cout, but into the stream parameter, we will put the value. Okay, strictly speaking, like this is all assuming that our double indexing is working. So this will make this code easier. We will simply index into opt right-hand side at position row and position column with a space, and add an end of line at the end of that, and at the end of everything, return the stream to support chaining. So should be all right. Now we can start testing it. The only thing we haven't implemented is the insertion operator, which we'll do once we've got everything else working. So let's see. Now time to find all of our mistakes, but instead of bringing in row, let's bring in grid. And let's make a grid. Let's keep it of integers. Okay, sounds reasonable. Right, so let's initialize it. Oops, not underscore. We're not inside the grid anymore. Okay, and let's initialize it. This will test our double indexing for modification at position row and position column. And let's just set it equal to, let's just have some counter. We will increment starting at 1, and then we should see reasonable outputs. And to test that, we can use the stream operator, or we could do so. Let's first, before we worry about the stream operator, let's focus on getting the indexing working. So let's just say testing indexing for output, so that we know what we're doing. Likewise over here, just keep track of exactly what's going on. This is allocating objects. Allocating grid. Testing indexing for inputs. And here we will do basically the same, except we will output the contents of the grid at that position. All right, let's see where we're at. Okay. Expect quite a lot of errors because we've been coding for a while. See the errors there. seeing anything there, but anyway. Let's have a look. All right, so default cols was not declared there. Let's see. It's at the grid, default cols. What did I call it? But you're from the grid, default rows, but default columns should come from the row.h. Oh, but it'll be like this. It will be row of type T : : default cols. All right. Let's try that again. Okay, doesn't like this. Oh, doesn't like you indexing into a templated one like that. Yeah, that might be a problem. Fine. Let's just do it the lazy way. Okay, let's try again. Oh no, I didn't take away the. Because the problem is, as I said, when the thing only exists once you instantiate it with the type. So accessing the static thing doesn't work because there isn't actually code for it at that point. It only gets generated when you specify a type parameter for it. I could perhaps do it for row of int default calls, but that just looks weird. So rather just move it out. Okay, didn't like you. Template argument 1 is invalid, so it's line 28. Feel like still calling a T1 over there. Just make sure that I'm not doing that in the header file. Okay, should be. Okay, rows not declared in the scope. That sounds like a mistake. Oh, right. I can't access underscore rows inside the where is this? Okay, that's a different error message, but we can fix that now. Here's so int index, that's fine. You are int index, not int row. Let's see. Okay. Rows not declared, that's line 63. Okay, that makes sense because remember this is not a member function. So it can't just be underscore rows, it has to be obj right-hand side dot. Likewise for columns, has to be obj right-hand side dot. So let's fix that one. Okay, now you don't like that C over there. That's me in the indexing operator, is it? Oh, right. No. What am I trying to do here? I'm gonna have to do, and yeah, I've got two choices. I could do an inner loop, or I can do the row at a time assignment. Let's do the row at a time assignment. Should be fine. Just think about this very carefully. Yeah, it should be okay. Okay, because we have an assignment operator for rows. You can assign a whole row. That's why we put an assignment operator there, and we tested it. So we shouldn't need to do the nested loop. Let's just test this. Okay, yeah, it's fine. Well, syntax fine. And max calls not declared in the scope. Did I mean max rows? Where did max calls come from? It came from here. You know what? Rather than muck about trying to access class constants from templated types, I'm just going to be lazy and avoid the issue one more time. Actually, it needs to be static, but whatever, it's fine. They can be static if they want to be. And that's that. Cool. All right, it's not formatted neatly, but it works. You agree? So we can see that we've got double indexing working. Maybe let's rather make it an array of, how many characters are there? Not that many. Let's just do characters. So blah, char, and then we can do a char And I don't know where we want to start. It's going to keep them formatable. I don't know. We'll see what comes after that. Didn't like that. Why? Where did that go wrong? It's interesting. I wonder why that. Oh, it's probably. Oh, no, never mind. I'm hitting some unprintable character that's killing the terminal. That's me being dumb. That's fine. Let's go back to integers. They won't format neatly, but at least it's correct. All right. So double indexing works. Let's just test the streaming and assignments and all of that stuff. So let's make a copy. So grid of type int. Okay. Test the assignment operator. Okay, and then we want to test the stream output operator, which I'll do initially on ObjGrid, and then I'll switch over to ObjClone once we know that the streaming is working. All right. Okay, stream the grid. Ugh, something was unhappy. Blech. Let's take a look. Scott's now, why is that unhappy? I am not sure. Let's take a look. Ah, right. I labeled this as a const but I'm indexing with something that can be a mutator, right? So because it's both a mutator and an accessor, it's moaning at me. So we'll have to take that const away. And likewise also in the declaration. Yeah, it can't be const because indexing doesn't have those guarantees. So let's try that now. Still some issues. It's different ones now. You know, you're moaning. I think it's a similar story for the assignment operator. Let me just check. Yeah, I've labeled this as const, but copy state, no. Where are you moaning? Let's just see. Const blah, blah, blah. It's 102. That's in copy state. So copy state is not constant. It can't be const because its job is to modify the state. So here, when we pass this, it's unhappy because this is a const. So we'll have to kill the const there. As I said, when we introduced const, correctness is you either do it everywhere or nowhere, because if you've got mismatches, then you're going to have to go and edit them all out in the end anyway. So let's fix that. Okay. Still think, yeah, and then there's something with the indexing operator that it doesn't like, but we'll have to see now. Oh, let's give it a whirl. Similar story here, I think. So this is in SIG 102 again. Ah, yeah, copy state. We have that flagged as const. kill and kill. Okay. Yeah, all right, so now we've got our indexing operator. It, as you can see, it works for input and outputs. The stream operator works. The only thing we've got left is to do the input stream operator. So for the input stream operator, what are we going to do? We're going to assume that the first two digits are going to be the size. The first two inputs are going to be the size, and then the remainder will be the number of rows and columns. Will be the actual contents rather. So let's do that. So int and rows. Stream to int rows. Stream into int columns. Now we've got rows and columns. So what can we do? We can resize. We can make our grid the size we want it. So we can easily do that because we have the functionality for that. So we first need to free its old data. Then we can resize it. The size we wanted. And then we can loop. Over all those rows and all those columns. Okay, and we can have now we can initialize those to what we want them to be. So S left-hand side, stream into obj right-hand side at position row and position column. And that should be okay because so as long as whatever the type T is supports the stream operator, we'll be able to stream into it like so. So that should be all right. And then we return the stream at the end. So let's test that out. Okay, and here we go. So we're going to say, oh yeah, don't know if we didn't test obj clone on the output operator on the clone. So let's just test that properly, make sure that works before we go any further. Yeah, it's fine. Okay, and then we need to test the other stream operator and just prompt the user that first two values on the stream must be the rows and the columns. And then we can go cin and stream into our, let's make a new one rather. Let's call it grid. Let's make it a grid of characters. Grid of char. Ch input. We'll call it, sorry, obj input. And stream into obj input. and then output it again. So we can see that the values were stored. All right, and let's see if that works. So keep it small so we don't have to type too much, like 2 by 3 or something. That'll be 6 values. Okay, so say 3 rows and 2 columns, and then A, B, C, D, E, and then F should be the last one, and then we should see our grid. Yeah, 2 by 3. Obviously it's small, but you can see it. Yeah, do a bigger one if you prefer. 4 by 3. And A, B, C, D, E, F, G, H, I, J, K, L, and you can see our little grid comes through. So we're able to do, it's a generic container of type T, so we can store whatever we want in it. As you can see, integers or chars or whatever. We can index into it with normal square indexing like we used to with 2D arrays, and we can stream into it and stream out it with stream operators, and we can assign it with the assignment operators. And just also note that it is complex to do it this way because it requires the creation of an additional row class, but the user of the type, the person who's writing main, doesn't know about rows. They just include the grid and then can use their 2D grid to their heart's content with double square indexing, happy as a clam. Right, so that's that, ladies and gentlemen. Thank you very much. I will upload the recording as well as the code for this. Yeah, we won't ask you to do templating as a requirement in the second semester test. It'll be optional. We do want you to do your coding on the VPL in the test for safety reasons, and we do want and we won't ask you to do double square indexing in the semester test because, as you can see, it takes a very long time to get that right. It's much quicker to do round bracket indexing. All right, thank you and goodbye.